In this session today, we look at data. Um, so the important thing about the data is that we need to know what's the difference between population and sample. In all the work we're doing in this study unit, we will focus on the sample. So we will go into some of the summation notation. This is just an example. You don't need to really worry about it. You can use the notes if I ask you something like this, but they will focus on how to work out certain things. Okay, so when we get to one or two of the examples, what I will cover is that we work out all of these formulas. So that we work out the mean. So the mean is basically the same as working out the average. So we take the sum of the numbers, divide by how many numbers there are. So I will show that in the when I look at Excel. Um, then if they ask about the weighted mean, one can work that out as well, but they need to give you the weights. Then the other thing that we will go into, and again, I will show you on Excel how to use that, is where we look at the variance and the standard deviation. And again, we can do it for population and sample. So we'll show you how to do that as well. Um, then the other important thing that you guys need to know is how to work out the slope of a regression line. Um, you might sometimes also get the regression line as y is equal to c plus mx. So that might also be sometimes how it will look, where that m, and in this instance the b is the slope. It's much simpler to work out the slope when you do it via getting two data points. So I will show you how to do that, so that you don't always need to be able to work out the formula. So I will show you how to work out the slope within the functions in Excel, but also how to work out the slope if we only have this formula, because basically the slope is the difference between 2 points. And if we just quickly show it, if I have that x and y point, and I have that x and y point, we can basically connect the two so that we can work out the slope. So I will show you how to do that if I give you data points. And then the other thing that I will also show you via Excel is how we work out the correlation coefficient R. But just for background and some of the theory behind it, if you look at this one, it is the R is -1, but it basically lies on the straight line. So this is a perfect correlation. This you can see it's also very good. It's spread around in a certain area. Here you can see the spread is much bigger. So here it is much smaller. So you can see as the spread becomes much bigger, your R becomes closer to 0 as well, where in diagram D, there's basically no correlation between the data. and then the data becomes positive when it starts looking like this again. So there you can see also very positive and very high because the correlation is very high. So we will show you how to again work out the R in Excel, because again that is much easier. Some of your financial calculators also have those abilities, so it will be good to understand what calculators everybody is using. Then you can also use formulas, and I will share with you a formula page closer to the exam date. But again, formula I would nearly use last, because we need to work out a lot of information if they don't give it to us. So if they give us information, then it's fine. So I will show you also how to work out the R. Okay, so let's get into one of the examples on, and this was from previous exam paper. So let me show you how to use Excel in this instance. What is nice about Excel, it gives you a lot of functions that are built in. What I will also do is I will share this one with you so that you can actually use it when it is already pre-populated. So let's look at, we've got X and Y values. I will make it a bit bigger. So X is 500, Y is 5, X is 900, Y is 15, X is 1500, Y is 19, X is 2000, Y is 7. Okay, so we've got that the four data sets, so we could work out a few things. So I can work out what the mean is for both of them if we wanted to work it out. So we can work out what the average of the X points. We can work out what's the average of Y. So if they ask us that, we have that information. If they ask us the standard deviation of a sample, we can work that out as well. So there is a nice built-in function that is standard deviation of sample. And we can work it out for the Y as well. So they haven't asked us that, but I just added it if needed. Then we can look at the correlation. So we're going to look at that first one of correlation, and there's a nice built-in function as well, correl. And in correlation, all that they want is the first data set and the second piece of data, and then it will work out the correlation for you. So the correlation, and let's just round it off. They've rounded it off to 5 decimals, so let's keep it at 5. So you can see the correlation is positive 0.16428. So for that first one, that would have been what we are looking for. What is very important, if your correlation is positive, your slope will also be positive. So whatever the sign is of a correlation, it will be exactly the sine of the slope. Okay, so very important thing that we need to know. But again, for slope, we can use the formula. So they want us to put the y's first, then the x's. So if we look at the slope, so now we can see that is positive, the correlation, so the slope is also positive. So by just looking at the correlation that was positive, we could have said, okay, let's go to the next question where we look at this. Okay, so slope was positive, slope positive, slope positive, slope positive. So all of them is still correct. Then we go and say, okay, but let's work it out. Then the slope is 0.00164. So now the options is 2 or 3. Okay, so then we need to work out what is your y cutoff. So what we will then do is there's also a nice function called intercept. So it will work out what the intercept is. So if we look at the intercept again, what they want us, very important, is to do the y first, the x's second, and then if we work out the intercept, we see it's positive 9,485. So there is the positive. So that will be our answer for question 16. What is important to note as well is it does not always mean if you have a positive correlation and a positive slope that your intercept will also be positive. So in this instance, it is true, but it does not mean it will be there for everyone. So it can be that your intercept might be positive or negative. We won't be able to just say because the one is positive, that stays positive. Okay, so what I want to show more is the same data or the same type of questions. The data is a bit different. So we can still use the same spreadsheet and see what we can change in the data. So here they tell us x is 0.5, the y was 1,000, x is 1, the y is 800, x is 2, the y is 500, x is 5, the y is 20. Okay, so what you would have seen now, because this is a built-in function and connected to the data, the information immediately changed. So now we see with this data, there's a negative correlation. So because it's a negative correlation, our slope will also be negative. But you can now see the intercept didn't change to negative because of the others. So just again showing that there's not a link between the sines and the intercept. Okay, so let's quickly look correlation, worked it out. Minus 0.98185, so that would have been the correct one that we're looking at. Then if we look at the slope, negative, so minus 207.59. Okay, so just by using Excel and the data, we were able to work that out. What should be also, and let's quickly test it, is if we worked out the slope by looking at, and this should be the same. So let's check if we worked out the slope by looking at two data points. So let's use this data point and this data point. So x2 is 20, 20 minus, or sorry, y2 minus y1. So this should be the same if we work it out this way compared to the number that we got from Excel. So let's just see if it actually does that. The x's are 5 and 1. So if we at the top, 20 minus 800. So if we see 20 minus 800, we get minus 780. 5 minus 1 is 4. So 780 or divided by 4. Okay, so we get something different. 195. Negative. Okay, so it is supposed to be exactly the same. So let me just quickly check again. It's 20 minus 800. 5 minus 4. So this should actually be working out exactly the same. I just want to check if we take other numbers. So if we set y 500 minus 1000, and if we set 2 minus 0.5, so that would have been at the top minus 500 and at the bottom minus 1. Plus 1.5. So again, interesting that this does not get us. So that would then give us minus 333. Okay, so it's interesting it doesn't give the same. I'm going to check this out a bit because it is supposed to give you, if I give you two data points, that you must get the same with the slope. So let me just check this method out, because this is worrying some if I give you this data, you should be able to say, I'm looking at two data points, X and Y, and I should be able to work it out this way. So let me just make 100% sure why this is not adding up, and not giving what we intend to get. So I will check this out for you, because it should be that you, unless you need to take the average of all three of them. So let me just check why this doesn't. It should be the same, but I will check for you guys why this didn't, so that we can look at a shortcut as well with the data. So that should have been the same. Okay, so let's just, why did this now change so small? Okay, cool. Okay, so if you then look at the next one, again, a set of data, um, the data looks different, but we can use, again, this spreadsheet. So I am going to use the exams spreadsheet, the same. The only difference now is there's an extra data point that we need to insert. So let's put that in. So when we look at X, it's 80. Y is 5,000. X is 120. Y is 5,500. X is 250. Y is 6,000. X is 300. Y is 4250. So it is coming down again, and then 400, and Y is 2000. Okay, so if we again work out the mean of each one, it is set to work it out for that whole section again, and for that one, so that is fine. Then if we look at this correlation, there we needed to work out correlation. So correlation is minus 0.72766, 72766. So we can round that off to 4 decimals to get there. So that would have been our correlation coefficient. We see it's negative. Because it's negative, the slope also needs to be negative. So because that is negative, the slope needs to be negative. So we can see that is negative, so that might be correct. That's positive, so it's not option 2. That's negative, so that might be. That's positive, so not option 4. And then if we work it out, we see it's minus 8.68, 8.68. So that is the correct one. And then we also have the intercept as 6547.46. Okay, so again, by just using the Excel, it was actually not too difficult to get the answers that we were looking for. Okay, so it will also be very important for me to nearly see how they ask this in your assignments, how they ask the question around the regression line and coefficient of correlation and those kind of things, so that we just make 100% sure that we are covering everything that you guys need to know. Okay, then there's a question that looks a bit more at the definition. Also important nearly to understand those things. So the square root of what is called the standard deviation. Okay, so if we go back to some of the definitions, here we had, so the square root of what is equal to the standard deviation. So it's the square root of the variance. And so again, you are allowed to have all of these slides with you. So the square root of the variance is called the standard deviation. Coefficient, correlation coefficient, coefficient of determination, that we work with R, and then sample is just the N. Okay, then again, they give us a data set. So again, you can see this is from a previous exam paper when it was still a printed exam. So let's just put in a different data point. So again, easier when we actually have the spreadsheet and we can just put in the numbers. So again, you are allowed to use the spreadsheet. So I will share it after the session on the WhatsApp group so that you can have access to it. So let's just see 143, 116, 500, 7, 98, 9, and 90. If they ask mean and standard deviation, the information is there. So the correlation, again, negative. Just want to make sure that's okay. So it's again negative. So that tells me that when we need to work with the slope, that should also be negative. So just linking the two again. So correlation, they only ask it in the second set of questions, but there we have it as minus 0.93. But because, again, the correlation is negative, we know that the slope must be negative. So not that one can be, that one can't, that one can be, that one can't. So even before we look at the options, we know that we can eliminate some already. When we look at the slope, minus 6.2, which is option 3, and then just to make 100% sure, we look at what the intercept is, and that is also correct. Okay, so again, it helps to have the spreadsheet. What you can also check on your financial calculator, if you have a financial calculator, is to, and with my HP, it's a bit different, the HP from the cashiers and the shops. So you need to put in the data as data points. Basically, that will be your first data point, second, third, fourth, and fifth data points. Then you will be able to use the R on your calculator to work out the correlation. There is, on my HP, there's a M for the slope, and then there's a B also. So you are then able to work out all the differences if you have a financial calculator as well. Okay, so again, just showing, and I will share this with you guys on the WhatsApp group, so that you can get access to it. And then the last question was again a definition question. So here they said, okay, you've got a linear correlation coefficient of R equal to 1. So if we go back to those formulas or those graphs, so R equal to 1 would have been this one, but just lying like this. So it would have been positive 1. So if we look at what they ask us, so linear correlation coefficient of R equal to 1 that has been calculated for a data set means that the linear relationship between two variables is weak. Yes or no? Because it's 1. So the closer you get to 1 or minus 1, the stronger it gets. The non-linear relationship, okay, so no, because we're working with R, it is between two data, so it is a linear relationship. Between two variables,
is strong but negative. Okay, so strong is correct. Linear relationship is correct. But you can see it's +1, so it's not negative. So linear relationship, yes. Between two variables, yes, is strong, correct, and it is positive, correct. Okay, so by looking at just that one measurement, r equal to 1, we can say that we have a strong positive relationship between the two variables. Okay, so what I will add in here is just some numbers around what is strong, what's not. We can see it out of this diagram, so we can see it out of this one. So strong negative because it's minus. Again, strong negative. This is a weak negative. If you look at this one where r is equal to 0, there is no relationship. So when r is equal to 0, there is no relationship. Then we get to r equal to 0,6, so strong and positive, and then this one also strong and positive. Okay, so that just again shows the relationship between two variables. So just a quick recap of what is important in this section is we looked at, or I added the mean and the standard deviation and variance to the Excel spreadsheet, so that if needed, one can work that out. Then we looked at a linear function with slope and intercept. And linked to that linear functions nearly is also your correlation and regression. And then we did a bit on the scatter diagram. And if we need it, and let's put that into one of the Excel numbers as well. So if we needed to get, that is your, and let's quickly show the correlation of coefficient is your R. So if you needed then to get your correlation of determination or the coefficient of determination, let's just remember that is your R square. So then all that we do is we take that correlation of coefficient and we square it. Okay, so again, it is possible to do that in Excel. And let's just get that smaller that we can work with that. So we can get that in Excel as well by basically saying the coefficient, the correlation of coefficient, we take the power of 2, and that will always be positive. Okay, so the coefficient of determination will always be positive because a negative times a negative will give you a positive. But if we had the positive, the positive times positive will always also give you positive. So that's why this one will always be positive, a coefficient of determination, because if it's positive times positive, we will get a positive. And if it is negative times a negative, we will also get positive. So I think that just, again, is important to see that link. So coefficient of correlation or correlation of coefficient is R, and then the determination one is R square. Okay, so just that if you ever have a question around that, so again, please, if you can please share the last um, assignment you guys did, that I can just see how if they have asked anything else around that. Okay, so that is it for today. So we just again remember how to work out the mean, um, standard deviation, and variance. Yes, please ask the question. If you can maybe repeat or even type the question. Um, Weird, I can't hear you that at the moment. Okay, so what I will do is I will share the slides, I will share the recording, I will share the Excel on the. When is your mock exam? The mock exam is normally a very good view of what your exam will be like. So the mock exam is normally, and there's nothing really on the topics. If I look at, so what they normally do is they will look, and let's look, there's about 8 chapters. Your mock exam is normally around 25 questions, so they will have about 2 or 3 questions per study unit. So it's not going to be like it's they only focusing on the last 2 or 3 chapters or anything like that. So your mock exam covers everything, and it will be very similar to how your exam will be. So and the exam is also, there's not like they will favor cash flows or bonds or something like that. It's normally a very good representation of your work. So what they normally you will get is around 3 questions on simple interest. So they will give you normally a simple discount question. They will give you a simple interest question, but it might be that you need to work out the interest or the time component, and it might be that again they do it in days or something like that. So they love asking the simple interest with counting of days. So about 2 or 3 questions on simple interest. Then they go into compound interest. So there they would
focus a lot on the different components of compound interest. So continuous compounding, they love to ask a question where they start off with simple interest for number of days, when you get a component that is compound interest, and then you end up again with a component that is simple interest. So that they love to do. And then there will be part of that compound simple interest component will be also the change in interest rate. So from a nominal to effective one, or from something that is quarterly into monthly. Um, then they will go into annuities, and important with annuities, there will always be one of the annuities that will be annuities begin, so that it's the beginning of the month, and then there will be a question around a normal annuity that is paid at the end of the month as well. So annuities, it's normally those two, where they can also then have it as different periods again, where they might throw in quarterly interest rate or things like that. Then they go into amortization and the sinking fund. So again, what they will look at is paying off a loan. So there they can ask a few things on maybe what is the repayment that needs to be done. The same then into sinking funds. They will look at the differences in there. Then cash flows, there's about 4 or 5 different cash flows that they can ask, and they're not gonna ask all 5 of them, but they might throw in about 2 or 3. So the ones that they normally look at is the net present value, the MER, and the internal rate of return. So that will be your cash flow questions. Then on bonds, there's normally 1 or 2 questions on bonds and how that work, and then one on debentures, and then there will be, like we've done today, questions around working out the slope, working out the R, so the correlation, and it might be the same data set, or it might just be 2 different data sets where they then will ask you to work out the mean and the standard deviation as well. Okay, so that's nearly, so it's nearly on every component of what you've done, there will be 1 or 2, or let's say 2 or 3 questions. So that nearly gets us to around 3 times 7, because there's about 7 chapters, 21 questions. So, and I think the mock is around 30. So then 25 to 30 questions. So that is how it might then be 4 questions per study unit, but that's nearly how it is structured. So I hope that will assist you, because again, the mock exam is very close to how the final exam will be. So always good to do the mock exam to see how it will be. If you can, when it's done, send me the mock exam. That will also be great, so that we can also just go through the mock exam as prep for your final exams as well. But that is nearly a very good outline of how the mock exam will be. Okay, so that is
it for today. Next week, we will start going and working through exam questions. So from next week, it is basically exam prep. So we will just go through questions that I have. If there's any other questions that you might have that you had during the assignments this semester, during the mock exam, please send that on and I will just add that to the pack, and then from next week we will just go through examples by examples. And that is, for me, the best way is nearly to get to what we need to just practice examples so that we nearly cover everything that they will be asking you in the exam. Okay, thanks for joining. Um, yeah, it's been not a lot of students joining today, so thank you from the bottom of my heart that you joined so that we could get this session done. And yeah, then from next week, we will start focusing on the exam prep and make sure that we get enough examples in for the exam. Okay, have a wonderful weekend, and then we will see you again next Saturday. Thank you once again for joining the session. Cheers.